Thank you for joining us here tonight. For those of you who don't know, I'm Anjali Goswami. I'm the president of the Linnean Society, and it is my great pleasure to welcome all of you and our speaker for tonight. Can I just say, how many people here are not members of the Linnean Society? Oh, quite a lot. Okay. Well, I like to think of you as future members. So for those of you who don't know, the Linnean Society is a really broad tent of people who are interested in the natural world. We have scientists like myself. My day job is at the Natural History Museum. We have artists, historians, amateur naturalists, really anybody who's interested in the natural world and shares our vision or mission, really, of building a global community of people who are working to improve the understanding, the valuing, and the protection of nature. So if that sounds like you, come find me or any of our staff members or other fellows who are here tonight, and we will convince you why you should join with us and work for positive change for the natural world. So with that slight plug, it is my pleasure to welcome our speaker, Professor James Bullock from the UK Centre for Ecology and Hydrology. James has a really incredible research portfolio with an amazing, what I read was 280 publications, which is a really vast amount of work, and including editing two books. And his work is really focused on spatial dynamics and management of biodiversity, specifically using statistical and mathematical modeling of ecological dynamics on really large scales. A lot of his work has focused on really critical topics that many of us are interested in, things like ecosystem service science, sustainable farming, and conservation planning, and really coming up with ways of solving the biodiversity crisis. In fact, one of the major things that he's been working on at the moment is really developing the national capacity to bridge net zero and agroecology. So we will be hearing about a lot of this, especially in the topic of rewilding and restoration science tonight. And so without any further ado, I will hand it over to our speaker.
Thank you very much, Anjali. So yes, I'm going to talk about something which should be very close to our hearts about the ecological emergency and how it's probably going to get worse under climate change and what the hell we can do about it, or ideas of what the hell we can do about it. And I guess what I'm going to do is touch on some fairly controversial subjects. And so I'm going to say now, especially since my boss is here, that this is my personal opinion, not the opinion of the UK Centre for Ecology and Hydrology. I inserted that yesterday and I realised Stu was going to be here. Anyway, so without further ado, I'm going to just arrange across a range of subjects, following an arc of what we do about conservation in the future, touch on biodiversity loss, which we all probably know a lot about, what the drivers of that are, what's going to happen or what we think might happen in the future, and how we might need to change how we do conservation in order to address these future challenges. And at the end, go on to how we actually make it happen, thinking about the more social and political spheres. So biodiversity loss, it's in the news, not as much as climate change, but it's certainly all in the news. You can see a range of newspapers over the last year talking about the sixth mass extinction. I also have to pause to say it properly. And it seems to be fairly well accepted that certainly biodiversity loss is massive and continuing, whether it's a sixth mass extinction. With a paleoecologist in the audience, I'm going to be careful about what I say because it's very controversial. But the evidence is quite overwhelming that not just have we in the past destroyed biodiversity, that destruction is ongoing and not really slowing. So globally, we have things like the Living Planet report, which shows a massive loss of biodiversity. This is from a fairly short period. That, oops, my dot's gone. Anyway, that thing at the far right-hand side is 1970. So just over the last few decades, we've lost a huge amount of biodiversity globally. The State of Nature report for the UK shows very, very similar points that we've lost a huge amount of biodiversity, not just historically, but in the recent past. And I think the most compelling stuff is along the bottom there about loss of habitats which is probably, to my mind, more important than declines in species, although the two are closely linked. So that's also, you probably all know about that in some way or form. What are the causes of this biodiversity loss? Obviously humans, but there are, as ecologists, we try to look at it in more detail. So this is some work we did a couple of years ago, asking biodiversity experts across the world about what they thought the main drivers of biodiversity loss were. And these maps just show where they pinpointed where these main drivers were more important or less important. And the big maps show the terrestrial sphere, and the ones over there or over there are the marine. But anyway, to cut a long story short, what the consensus is that land use change is the main driver. That's our use of land for agriculture, for building on, for infrastructure, all these things we do to take land away from the use of other species. Second most important, climate change. Then you've got things like overexploitation, our exploitation of other species, our overfishing, our hunting of species. Things like pollution, pesticides, nutrient pollution of the world. And the fifth one, invasive alien species, which again, an important one. But I think this shows a huge consensus about the order in which these drivers operate. And I think that is a problem for conservation science, because as the headline here says, a lot of conservation ecologists and conservation practitioners focus on this land use change, about converting land for agriculture or other uses, and slightly ignoring the obvious point that climate change is the emerging threat. And I think, put my thesis forward right now, I think a lot of conservation ecologists think of climate change as something we need to stop rather than something we need to adapt to, which would be great, but it's not very realistic. And so this shows, a couple of papers here shows our response to a paper which said, we're focusing far too much on climate change, we should be thinking much more about land use. And we said, yeah, that's okay for the past, but not the future. And what we said is, given the accelerating and non-linear nature of climate change and its impacts, the recent past is not a reliable guide to future change. And conservation must look to the future. That's going to be my theme throughout this talk, and I'm going to repeat it again and again in slightly different ways. And the reason we have to think about that is the graph on the right, on the left, your right, anyway, that graph shows projections for climate in this country. And I don't know how much you know about these different projections. So we've got different lines going in different directions from the current day, from the most extreme, probably less likely form of climate change, the so-called RCP 8.5, to the least extreme, most moderate RCP 2.6. The reality was somewhere in between, but they're all showing even the most moderate climate change scenario is still a vast increase in average temperature over the next century compared to now. So this is what I mean by accelerating and non-linear. So given all that, the threats to biodiversity, what climate change is doing, does that mean we can get away with just doing more conservation as we've done in the past? And that tends to be the way people talk about it. So going back to the UK State of Nature report, again, this isn't to criticize it, it's just to criticize or to think about what conservation is about, and maybe we need to change the way we do it. But this talks about doing things along the lines of looking after threatened species or managing protected areas, i.e. nature reserves, doing some more ecosystem restoration. All sounds well and good, and it'd be fantastic if the climate wasn't pulling the rug out from conservation. And let's think more about why am I being so down on traditional conservation? Well, traditional conservation is very much thinking about the past. You can sort of characterize it as thinking about protection and keeping and moving back to the past state, because the past was much better. We had more biodiversity then, so why not go back to that in some way? And Charlie Gardner, who's in the audience here, there, Charlie, and I wrote this paper a few years ago where we sort of laid out a lot of the ideas I'm putting forward today. But we said traditional conservation is very much focused on maintaining or maximizing species persistence in the short term, preventing and reversing biological change, and prioritizing what we have now through things like protected areas, etc., which I've just listed. And so we tend to focus on these lovely species which we see on the television all the time, things we should be really focusing on, conservation say, to get things better. And even when we think about what we do about the future, I think conservation still implicitly thinks about historical states. So some of you may have come across this idea of bending the curve, which is the big thing everyone in conservation talks about now, and it's in international agreements, etc. So what this idea is, the black line you can see here shows biodiversity's been going down. This again shows that 19th century thing, but of course if you went beyond that, you'd be going shooting up through the ceiling. But anyway, even starting from 1970, it's looking pretty appalling, and then it's saying, well, we need to bend that. If we carry on, we're going to do that blue line, it's going to carry on going down, you're going to just have a couple of species in the landscape. Ideally, we'd follow the green line and do all these things to get biodiversity back. But again, that future looks a lot like the past. And that is implicit. It's not what people really talk about. It's sort of almost so imbued in how we think about conservation. People don't even question that. And so to give a more concrete example, ecological restoration, which I work on quite a lot, is all about returning to some past state. And there's some technical language about it where people talk about reference communities or native ecosystems. I also find a rather odd concept. But usually they're talking about some nice type of ecosystem, not the nasty ones, but a nice ecosystem we want to return to. So examples where where we've mined land, or we've trawled coral, or we've logged mangroves, or we've ploughed up land for arable agriculture. And we want to return to what these pictures on the bottom, those nasty things at the top, the pictures on the bottom are sort of our target states. And restoration ecology has practices come up with all these amazing techniques to get it back to that past state. So we do that quite well in a relatively stable climate. So let's dig more into why I'm so worried, or why we all should be so worried about what climate change is going to do for conservation. So this is some work we've been doing, led by my colleague Rob Cook, where we've looked at projections of climate in the future. So we can do some very fine resolution projections about what the temperature is likely to be under this scenario or that scenario in 1 kilometre squares. It's not saying this is truth, but it's just looking a set of assumptions, and we project into the future. And what these rather complicated maps are showing, which is that if we look at how climate is projected to change, and how communities of species of plants, which is this lot, or birds, say on the other side, how their communities are linked to the climate in which they're living. So basically, everything lives within what we call a climate envelope. If you think about communities of species, that envelope is more complicated. But what our modelling is showing is that it's two things, especially for plants, less so for birds, but still quite importantly for birds, that across Great Britain, under even the moderate climate scenario, RCP 2.6, but especially under the most severe RCP 8.5, we're going to see communities of species are going to see the climates they live in now disappearing, so-called disappearing bioclimates, and also new climates arriving, which they have never experienced, which no other groups of species have experienced in the country. And these maps just show the hotspots of where those happen. And what's interesting is the novel and the disappearing bioclimates are in different places. It's a bit complicated, but basically I think take home is that what climate change is going to do is really change the conditions in which communities of species live, such that they're unlikely to be able to live there in the future. And come on. So that's a big problem if we look at average climate change, the average temperature change, precipitation, things like that. But it's even worse than that. If we look beyond average effects, the climate change throws up even more problems for conservation of biodiversity in the future. One is that I mentioned those 5 drivers of biodiversity loss: pollution, overexploitation, land and sea use change, and climate change. And what we know from the literature, and this is going back to our expert survey, that these things don't just act alone, they interact synergistically. And synergistically is bad in this case because they make things worse. It's not just you have climate change and you have land use change, and they're additive, they're multiplicative. There's more and more evidence for that. So a great example is you have invasive alien species which cause a huge problem for native species. Climate change makes things better for a lot of those because they come from elsewhere or warmer parts of the world, and so they actually exacerbate the impact. And things like land use change interacts with climate change, where we actually make conditions worse for species, and then we throw climate change at them. It's getting harder and harder. So synergistic interactions with other drivers. Climate change will not only change the average temperature, precipitation, etc. It's also going to increase climate extremes. And the work I mentioned just now, this one is led by my colleague Emma Robinson, where we again projected future climate, but could also look at extremes. So even under the moderate climate change, ICP 2.6, but especially under the most extreme, we're going to see, likely to see a huge increase in days of extreme heat compared with the current climate. And also rainfall, we're going to see a greater return, sort of increased return time of extreme rainfall. So more likely to have floods, more likely to have extreme heat, and many other aspects of climate change. So this is something not just we have to deal with, other species have to as well. Other aspects of uncertainty about climate change is that there is this idea species can just move around, rearrange themselves under climate change. And that's going to be very difficult for plants, which aren't very good at moving around and finding new places. But a theoretical piece of work I did a few years ago showed that even things like mammals, which are quite mobile, a lot of them, even if everything was perfect, we had nice green spaces for them to move across, and we weren't stopping them with roads or shooting them or whatever. Even with that, with their natural dispersal ability, would not move fast enough to keep up with a changing climate. So like, we're in London now, a species that is in London, future times it's got to go to Inverness. It's just not going to get there in time. So it will go extinct. And the final one is so-called extinction cascades, which is basically, if you think about it, no species is an island. Every species lives by interacting with other species. And what this study, which I wasn't involved with, showed is that if you include the fact that if you knock one species out of a system, other species will follow because they're dependent on it in some ways. You get these co-extinction effects. And basically, overall, they see, especially some parts of the world, a massive impact of that. So climate change having a much bigger impact than just knocking out individual species because they don't like the climate. Other species will follow even if they could live in that climate. So it's summarized in this cartoon here, which I changed the speech bubble for. So basically, we can't carry on doing conservation as we have done for the last few decades or 100 years because the conditions are changing. So the old ways is not an option. So that's all well and good. So I've thoroughly depressed you now. We're all screwed. What do we do about it? Well, we're still screwed, but maybe we can do something about it. So what we came up with, and this again, going back to work with Charlie Gardner, is we wrote something, we came up with the idea of what we called survival ecology, which I'm not going to say is a rather grandiose thing because Charlie's in the audience, but we want to put a new label on it. And what the idea we had here was that, I'm not going to read all that out for you, but basically, go to the third bullet, the prospects for preventing further extinction and loss of biodiversity becomes ever more remote in the climate emergency. So what conservation should be doing is rather than focusing on keeping species, keeping the ecosystems we have, keeping the habitats we have, we should be thinking more about the promotion of complex, well-functioning and resilient ecosystems, which should hopefully help them adapt to a future climate. I'm going to go into detail about that because it sounds rather esoteric at the moment. But also in this, we suggested not just that's what should happen, is we should thoroughly change the way we think about conservation. So we suggest a paradigm shift from biodiversity conservation to survival ecology. And the reason we came up with that term, or Charlie came up with that term to be fair, was the idea of refocusing the field on safeguarding a planetary system which humans and other species can thrive. And what's interesting is this is a bit out there a few years ago, but it's getting there, it's getting out there. People are starting to think about it. And when I give talks around this, I always expect people to throw things at me. There's always time today. But I often get very positive feedback saying, yes, we do need to rethink what we're doing. And even the recent Oxford very short introduction to biodiversity conservation had a quote from us in there, or quoted us in there. So hopefully our message is getting out there. So to break that down a bit, what do we mean by that? I gave you the traditional conservation. So I'm pointing that one. I know there are two things, but I'm only one person. But under the conservation column, I explained to you about this idea of maintaining things, resisting biotic change, prioritizing what we have now or had in the recent past, protected areas. And I'm going to read this thing out, which sort of re-says what I've said already, but rather than seeking to maintain a world which no longer exists, survival ecology acknowledges unavoidable change and seeks to shape the world that will. So we're looking to the future and not the past. And so that's what we've got under survival ecology. So instead of really thinking about current diversity, we're thinking about maintaining the conditions for complex life. It's as fundamental as that. Being proactive, so accepting the reality of climate change. I think a lot of conservationists are sort of hoping we can just stop it somehow and carry on as we were. And I don't blame them for that. That's really the way the logic of the idea goes. But we're saying accept the reality and seek to shape the outcomes rather than just resist. And so it's rather than prioritizing what we have now or in the recent past, we prioritize future functioning. So this is again about complex functional ecosystems. And the things we do around that may be different. So this is where you see rewilding comes into it, but also other things like assisted colonization, novel ecosystems, a whole raft of things which some of you might be new ideas or new thoughts, but I will break them down in the rest of the talk. So to go into a bit more detail about that, what should be the aim of conservation in an uncertain future? As I said, climate changing, and we're not exactly sure what impacts it's going to have, but it's going to be pretty bad. So should conservation be about species assemblages, groups of species which we like seeing, we're used to seeing in certain areas? Or should we focus on ecosystem processes, on systems which work and which are functioning well in the future? Should we focus on the identity of species or the complexity of the system? So to flesh that out more, have a look at these nice diagrams, which I didn't create, but Emily Waddell from Stirling University did in a research project called REST-RECO we've been doing. We've actually been looking at how this works on the ground. So you could have an ecosystem in the past which looked like the one in the future. This is Britain, so it's true blue. You've got all these nice blue British species doing their nice things of predation, pollination, eating detritus, etc. in a nice forested system. But as climate change hits, some of those species will disappear. So if we want to keep something which looks a bit like what we had and doesn't have any novelty in it, we could be moving to this one on your right. We've got a few things knocked out of the system. It's all a bit more depauperate, but they're all still true blue and doing their thing, but maybe in a lesser way. And I already mentioned this co-extinction idea. So they might be gradually going anyway because they're not being pollinated properly or there's not enough nutrient cycling. Or you could have something like on your right, so I'm getting right and left mixed up here, but you get my message anyway, where we've got all these colourful species coming in, which may not be from that ecosystem traditionally, maybe from other parts of the country or from other ecosystems or even other parts of the world, and I will return to that shortly. But we've got species doing the things species need to do in an ecosystem. It may not be the ones which you would have normally expected to see there. They may be purple rather than blue or pink rather than blue, but they're doing that job. So this is the idea of complexity in ecosystem processes versus identity. And just to really hammer it home, this is another piece of work we've been doing with Joe Tobias at Imperial College, where we promoted some similar ideas about focusing on process-based as opposed to traditional species-centric conservation. And we said, I'll read out the quote here, effective and sustainable conservation of ecosystems requires an integrated approach that extends beyond species conservation. Indeed, species identity is arguably irrelevant. And what Joe did for the paper was create this diagram, this food web, where you've got predators and plants which photosynthesize and produce resources, and you've got detritivals and things. So a sort of classic food web, but did it with AI. So all these species are not real species, they're just like exemplars. What's really fun is the journal likes the paper, but it says it won't reproduce AI-generated images because it's wrong. So we said, well, that's the point, really. But anyway, I think we've lost that battle, but I'll have to ask Joe. So it's a bit weird. So, but just to give the point that these are not necessarily any particular species, they're just doing their job. And I'm going to touch briefly on resilience now. So I said we need to allow resilience in our systems. What does that mean? So resilience in an ecological sense is you have perturbations like a disease goes through a forest, or you've got build-up of blue-green algae in a lake through nutrients going in, or you've got a wildfire sweeping through a system. A resilient ecosystem is one that can either resist or recover from that perturbation very rapidly. And that's what this graph shows. You can have very poor resilience, it just goes to a new state, or it's got very high resilience. And you've even got tipping points in there, which I won't go into. And the attributes of resilient ecosystems is that they're complex, they've got lots of components, and that allows redundancy, so you can knock out some bits. It's a bit like an engine. You can knock out, if you've got a very complex engine, you can knock out certain parts. It's a pretty bad analogy, but you get my drift. You can knock out some species, but it carries on doing what it's going to do. So this is the idea of resilience in ecological terms. So what do we do? How can we create these complex, resilient, well-functioning ecosystems? Well, I'm going to run through a number of different approaches, which are all interlinked really. And I guess one take home, there's no silver bullet. There's no one approach to rule them all. And we probably need to a mixture of things. So one is changing how we do ecological restoration. I've already said how it's traditionally about returning to the past, getting something back, getting that hay meadow back in where it was 100 years ago, bish bosh, job done. But what we're doing in this Restore Eco project is looking at the idea of restoring complex systems rather than target communities. And what that means in reality is things like this diagram you can see here, which is what my colleague Ben would call is a bipartite pollination web. But normal people would just see it as you've got a number of plants in a system at the bottom, and at the top you've got a number of pollinators that exist in that system, and the lines show which plants the pollinators visit. So this shows a very complex system, got lots of plants and lots of pollinators, but also each of those pollinators is going to numbers of different species, so it's all wonderfully interwoven and complex. Compare that with a simpler system you can see on the bottom here, where you've got not so many of anything, and what is visiting what is much more compartmentalized. So it's much fewer interactions and many fewer components. And what we're talking about in restoring is changing restoration about really trying to move towards that target system and doing things which allow these complex interactions to develop. So doing a diversity of approaches, mixing it up, not saying we need to get a certain type of chalk grass in the back or a certain type of woodland, but really trying to work out what will work in that situation and being adaptive, changing things if things go wrong. Linked to that is rewilding. So rewilding, I know is in the title, I'm going to spend relatively short time on it, but rewilding is often seen as the panacea. It's like, all these problems of climate change, do rewilding. And that is true to some extent, but let's dig down on what we mean by rewilding. So rewilding, especially in the UK, is things along the lines of allowing natural colonisation for woodlands to develop, allowing more naturalistic or wilder grazing, or reintroducing key species like the sainted beaver, which are all fantastic. And then what we have is these lovely visions of what rewilded futures might look like. These are taken from Rewilding Britain and Rewilding Europe. I do work with Rewilding Britain. I'm not dissing them at all here. They do fantastic work. But we have these wonderful views of what it might look like. I don't know how that eagle's carrying off that boar, but this is a vision rather than reality. So these lovely visions of what the future might look like. But I want to sort of dig into it more scientifically and think what rewilding can do given these problems I've told you about climate change. And it's summarized nicely in this figure paper by Jens Christian Svenning a few years ago, where he talked about the current global environmental emergency and how rewilding can take us away from that. And this is framed around an idea of rewilding which aims to establish self-sustaining and complex ecosystems with interlinked ecological processes that promote and support one another while taking away human interactions or reducing them. So this is all around the idea of complexity, promoting interactions, getting everything working together, and that resilience. And we explored that here. So it sort of shows a more concrete example where we actually are trying to promote a number of things in rewilding, like that complexity of the food webs, allowing things to move around, and also allowing disturbances into the system. By allowing the system to adapt to disturbances, it can actually become more resilient in the future. And these two diagrams show that. The top one, A, is a sort of what we have now, these really depauperate ecosystems with those food webs of the dots of the lines. They haven't got many species in them. They're all separated from each other. They can't not really, there aren't many connections between different ecosystems because we've got roads and barriers between them. And what happens when you have a big disturbance, it could be a flood, a fire, or whatever, is it knocks out some species. And because it's all in pieces and not very rich in the first place, it really responds very badly and so recovers poorly. Whereas a rewilded landscape, you've got these much more complex food webs and you've got really good connections. Like in this case, it's like we've actually got green bridges over the roads. So it's an intervention. It's not just letting nature take its own path. And here we're allowing disturbances like fires to happen naturally. So what happens when these take place is the system's in a much better state to respond and recover from these disturbances. So rewilding certainly can do that, but it has to really go down these paths rather than what I'd say is rewilding as defined by people who want to do something which they're then called rewilding, to put it in a nutshell. I think rewilding has to have a vision about the ecological processes we're trying to achieve rather than just saying, let nature take its course. So a couple of other things which are more sort of breaking in this area, and how are we doing for time? I'm doing quite well, is assisted colonisation. So I talked earlier about species, even fairly mobile species like mammals, are going to find it hard to move in response to climate change, to track where their new climates exist. And assisted colonisation has been around in the literature for quite a while. And it's fairly obvious what it means. It's people finding a species somewhere and saying, oh, you don't know what you're going to do very well in the future, we're going to move you elsewhere, and you're going to do well. And that's really the traditional approach to assisted colonisation. What we've done, again, work with Charlie Gardner, a very recent paper we put out there saying, well, actually, maybe we should turn it on its head and say, rather than trying to save species, we should be doing assisted colonisation to save ecosystems. And we use the example of southern British forests, which under climate change of extreme heat, fires, etc., could see huge extinctions even of trees in them because they're not adapted to a future climate. So the idea there is, should we, and they're not going to be able to be recolonised from the continent because they've got the channel in the way. So we're in a particularly bad situation compared with the green here, which is on the continent where things may be able to move to some extent. But here, they've got the channels to get over. So the idea is that maybe we should start creating new, non-native, but near-native communities to be resilient to future climate change. So basically, again, taking that functional approach rather than focusing on identity. And again, this idea is just to get that debate going, let people thinking outside the box. And I guess this all wraps up in the concept of novel ecosystems, which the idea has been around some time, and I guess you might guess what it's about. And when it was first introduced a decade or so back, it was the idea we're starting to see ecosystems pop up that look very different from historic ones because of human influence, because we've changed the soil, we've changed the nutrient conditions, we've changed a number of conditions, and we've changed the biotic components, the species in them. And one example is Kai Ballast near Porthmadog Harbour, which is a mixture of native and non-native plant species. But what's very interesting is novel ecosystems have really been seen, and still is seen as something, well, these things happen because we've impacted the natural world. And so should we accept them or should we worry about them? Again, what I'm arguing here for is a more proactive approach and say, actually, is novel ecosystems the way ahead? Should we do all these things, this rewilding, this new way of doing restoration, assisted colonisation, to create bespoke novel ecosystems, which hopefully will cope better with climate change? So I don't know how many of you know the Lawson Review, where it came up with these four terms: bigger, better, more, and joined. I thought, in a sort of side tribute to that, it came up with 4 things we need for UK nature recovery under climate change. And I will do slightly tongue-in-cheek if you look at what acrostic that spells. But basically, the idea is we need a diversity of approaches. We need complexity in there. We need to be heterogeneous. We need to be doing things everywhere, not just where we decide to leave aside for nature. It needs to be everywhere. So permeating, even in our cities, needs to be multi-scale. We need to assist nature and not just let it develop by itself, because it's not going to do that well. And we need to be dynamic, resilient, and adaptive in what we do. So in the last few minutes, I'm going to move away from those sort of ideas of conservation and think more about other aspects of making it happen. So one argument is often thrown back at conservationists about the fact we need to put aside more space for nature, we need to do all these things, is, oh yeah, but we need to feed people. We can't possibly give up more land because we need to feed people. Well, I think the Dimbleberry report, which was commissioned by the previous government, and it's sort of not really seen the light of day, because probably it was saying something that some politicians don't want to hear. I won't get too political, but I will. But what this report said is a bit back of the envelope, but still a very compelling argument. They said by halving food waste, increasing crop yields, I'm not quite sure how we do that, but never mind. But I think the big thing is eating, not just stopping eating meat, but eating less meat, 30% less meat. That's not a big ask, really. They calculated we would be able to feed the UK on 1/3 less land. There's a huge amount of land which could be available for nature recovery. And so it shows it's possible. It just shows we need the will to do this. And one aspect of the will to do this is the role of scientists. So I've been talking about my role as a scientist is trying to ask the difficult questions about what do we do about climate change, what are the scientific solutions, etc. There is also an emerging role for scientists to actually be more advocates and activists about it. And I think it's really summed up in this nice quote by Professor Amanda Power of Oxford University. I think Oxford? So Catherine's, yeah, it's Oxford, isn't it? Where she said, we should now be asking whether we still believe that the best thinking for the 21st century is really done to remove from a profound personal investment in a livable future. And she was talking about academics, the old classic ivory tower, we just do the science, we don't get engaged, and saying that is no longer feasible. And a nice paper here, again, led by Charlie. I keep name checking Charlie here because he's so fabulous. But he and various others have been writing papers, etc., the last few years, saying that traditional academic roles, research and teaching, are not sufficient. Not they shouldn't be done, but they're not sufficient to drive transformative change. And we have a moral obligation to provide leadership. So that's a real strong role for scientists and researchers and academics to actually get out there and say, we know what needs to be done, or we have an idea what needs to be done, and not enough is being done. We need to get out there and represent things. And a big way of doing that is through activism. And you can see wonderful scientists for XR with a famous television personality in the middle there, really getting out in the streets and making that message. And actually there will be another one, 13th of May, where we're going to go to Parliament and represent these ideas. And this is just being out there, being active, being disruptive, being non-violent, to get that message across, because more and more of us are seeing this. It doesn't really matter what political party you follow, there's not enough action happening by politicians or generally across society to make these things happen. So I'll finish here, wow, bang on time, to summarize the argument. So I've mentioned we face a climate emergency, which has many, many problems, including rethinking conservation goals. So we need to rethink how we do things rather than maintaining the past, think about the future, which includes trying to understand how we cope with uncertainty. And I've talked about promotion of complex, well-functioning and resilient ecosystems which benefit biodiversity. And I haven't really talked about this, but also humans as well. We can do that in the questions if you want. And also finally, there's an urgent need for action, and scientists and other citizens need to be part of that campaign. Thank you.